Hey everybody, today we'll do another video, and today we'll do a video on mathematics. It's going to be probably I would say kind of basic. Well, basic in the prince, I will say in the concept, right, of mathematics, but not the basic mathematics. I'm sorry to say that, because it's going to be calculus, which is a beautiful, beautiful, beautiful thing, right? Well, for me, okay. Okay, so basically what we're doing is we will be analyzing some problems, right? And which is basically, it's going to be in the area of shapes and graphs, right? So shapes, and graphs, right? So shapes and graphs, right? So basically, when we do mathematics, we analyze data. In the real life, we analyze Excel data, right? Excel sheets. As an electrical engineer, I have to analyze voltage, current, power, and we have to deal with graphs, right? So maybe a graph look like this, right? Based on this graph, being this is y and this is x, right? What I'm looking at a function, and I can see, based on this function, I see, right? Obviously, I can plot this in MATLAB. I can plot this using all the different types of software, even Python. But when I see this graph, I don't see this graph as just a graph. I see this graph as live stuff going in, right? Stuff going on in the graph, right? So I have a time, obviously. Time, this x-axis. Time passes. Obviously, time passes forward. Time does not pass backward. If I could reverse time, that I would solve a big problem. But I cannot reverse time, right? What I'm saying is, I analyze this graph based on some type of data that was given to me. And I can see that this graph has some points, right? Based on this, there's a point over here. Based on this, there's a point over here, right? Based on 0, I got this. Based on 2, for example, I got this. When x is 0, y is maximum, and when x is 2, y is minimum. So I analyze the data, and I said, okay, so what is going on in this graph, right? How these tangent lines are going like this, and getting closer to this, and then when I get over here, I get maximum. At that point, the tangent line is 0. Not the tangent, the derivative of this is 0, right? Because it's a horizontal, there's no change. Remember, Obama mentioned something about a change, right? But he never said what type of change it was going to be. But again, I'm sorry to mention this stuff, but I like to analyze the stuff, right? Somebody, if you say something with comes out of your mouth, I need to analyze that too. The same way that I'm analyzing the data, or mathematics in this case, right? Analyze problems in mathematics. So this slope is getting closer and closer and closer, and finally touching that. And you can see if I am going in that direction, it's going to be a positive slope. If I am going in this direction, well, it is a positive. No, it's not even positive or negative because it's the tangent line. It's horizontal. There is no slope. There is no change. There is no change in x or change in y, right? It's a constant. And the derivative of a constant is 0. Now, if I do a tangent line like this, you can see that this line is going like this, right? In this case, the slope becomes negative. It becomes a positive. You can see that it is increasing and increasing to a certain point, and then flat, and then start going down, right? Positive, negative. Okay, so we have to deal with stuff like that unfortunately, in engineering, and I think that only engineering can, this stuff is applicable in many fields of, in many fields of life. For example, you analyzing some type of economic growth in a company, you need to see how the data is changing according to time. So based on that, we have to analyze we have to do a problem, or we don't have to do it, but I guess that's why we are here for, right? We need to learn. Okay, so the problem is the following. It says find the point of inflection and interval of concavity, right? Problem is, example, right? Finding the point of inflection and intervals of concavity and intervals of concavity find it, okay, and then find the point of intervals of concavity of, right? And the function is the following. Okay, so that is basically the example, right? And then our job is to find the intervals, right, of concavity, right? Now, Now, the problem is the following. So f of x equals 3x to the fifth, 3x to the fifth minus 5 x to the fourth plus 1. Okay, so that is the problem, right, given to us. Okay, so the first step right here is to find the point, which is called step 1, right? Step 1. Find the first derivative, right? Step 2, find step 2, right? Use, I will say use the first derivative to find the critical point, right? Okay, so step 1, find the first derivative, right? Now, notice that the critical points are the points where the first derivative crosses the x-axis, right? Those are the critical points. Okay, so let's take the first derivative. So f of x becomes the first derivative. F prime of x, the first derivative, that is coming to the front, right? That's equal to 15 minus 1 from the 5 is x to the fourth, right? The derivative of this is minus, bring that to the front, multiplied by that is going to be equal to 20. The derivative of this guy is simply 0, but we have an x over here, so we put x to the third. That's the first derivative. Now, I set this guy equal to 0. So f prime of x, right? F prime of x equal 0. What is f prime of x? Is this guy. So I set that equal to 0. So in order to find the critical points, I can say that by setting it equal to 0, right? So I take this guy, make it equal to 0, and I got 15x to the fourth minus 20x cubed. I have some common factor, right? So what I do, I take the common factor out. And what is the common factor over here? Well, the common factor over here, in this case, right, if I take the x cubed out, and I take 5 out, right? I get that it's going to be equal to, if I take 5 goes into this 3 times, 5 goes into that 4 times, which is equal to what? It's equal to what? It's equal to 15, yes. So that is going to be equal to, like, it's going to be equal to 3, right? And 4, right? So basically, over here, if I pull out a 5, I can pull out a 5, right? Which is going to be equal to 5x, right? And pull out an x at the same time. The maximum that I can take is the lowest power in this. So x to the 4th, x cubed, I pull out x cubed out, 5x cubed, and put a parenthesis. Inside, I have a 3x, 3x, and I have a 4 inside. Now, after we do that, because technically, do we actually have to do this in the point? Well, this is the critical point, right? Now we do. Okay, so the critical points in this, just in case we need it, because sometimes you need it, right? So basically, I set this guy equal to 0, right? And then I divide. So if I say 5x cubed equals 0, so x is equal to 0, right? Divided by x, whatever, it's going to be 0. And if I say 3x minus 4 equals 0, right? Add 4 both sides, and x is equal to 4/3, right? Those are the critical points in the regular first derivative. It's good to have this information because eventually, if the second derivative test doesn't pass, we have to refer to the first derivative test, and we have to use the critical points. Okay. So now we got that, right? Now we go ahead and take the second derivative. And take the second derivative, right? So the second derivative is going to be, it's going to give us another set of points. And the set of points is going to be the following, right? So let me just do that here. So the first derivative, we got this guy. So we got, let me do it over here. So it's going to be 15x cubed, 15x to the 4th, right? So okay, let me just, okay, so f prime of x is equal to 15x to the 4th minus 20x cubed. Second derivative, right? Bring that guy to the front. I get second derivative. That is going to be equal to, bring that to the front. That is going to be 60 60x cubed minus 60x squared. Okay, now we're setting this guy equals to 0 again. Set this guy equal to 0, right? So 60x cubed minus 60x squared equals 0. Right? We want to see where the second derivative is crossing the x-axis somehow. This is the second derivative, right? Set it up equal to 0. Factor out whatever I have in common, right? Maybe common sense, I guess. So if we have some common sense right now, in 2023, maybe there's some common sense still around. We can pull out something, right? We can pull out something, and that what it's going to be pulling out is something in common. In this case, we have a 60. In this case, we have a 60, and we have an x. We go with the lowest power coming out. The 60 also comes out, and I get 60x squared comes out, leaving me with an x inside. And that x is, I keep it over here, right? Because I pull out a 2x squared with a 60, leaving me with the x inside. And then I pull out the 60, but in order for me to multiply that across again to get 60, I need 1. So that is minus 1 is equal to 0. Okay, so now I got this. Almost there. Again, I do my little thing right here, and I say 60x squared equal to 0. Therefore, x is equal to 0. Then I go inside, and I say x minus 1 equals 0, right? So therefore, x is equal to 1. Okay, so x equal 0 and x equal to 1. Right? So now, okay, so now we do have something like this. Right? What is going on over here now? Okay. So we have some points, and we have that we have 0, 1 as a critical point for a second derivative. Usually we use the second derivative for test for concavity. If it doesn't work, sometimes we refer to the first derivative. Critical points. Right, so basically these are called critical points. These are called the deflection points. Now, so they call zeros, also they call zeros, right? So now we have to do something, right? Which is a very interesting. We have to do a little chart. Okay, so now we have to do a little thing that is called testing for concavity. Okay, so now before I do that, I gotta do something about concavity. Concavity goes like this. Think about this. You hold a cup of coffee. Maybe a cup. I hold this. Hold it like this. What is the concavity? just here. I have to put my hand in there because it's concave down. This concave is down. This concave is up. Therefore, this is concave down. This is concave up. Okay. So now you're seeing, right? I am holding the cup up. It's holding something inside. This can hold something. This cannot hold something. If I flip this down, it's not holding anything. Right? Again, I get this glass, hold it like this. I have to put my hand in there because otherwise those markers, they come out. See? If I put it like this, I don't have to. See? Concave up, hold something. Concave down, it doesn't hold anything. Okay? So, with that being said, this is concave down, this is concave up. Concave up. Right? So, let me do a little chart, and we need to do that. Because we need to understand this in order to see when we do a little chart where we're going, right? Now, let's go. Right? So, the first one is called interval. Interval. The second one is called test value. Test value. The third column is called sine of x double prime. Sine of f double prime of x. And then the behavior. Okay, so in this case, we're looking at behavior. Behavior, right? Of the function. Okay? Of the function, right? So now, of f of x. Okay, so now we got something, right, to work with. So first of all, we need to do something. We need to go to analyze the graph, right? So remember that the original function was the following. The original function was f of x is equal to 3x to the fifth minus, I think it was 4. It was 4. No, it was 5. 5x to the fourth. Right? So this is the function. Plus 1. Okay, so I like this. Actually, I like this one. Do something plus 1, right? Interesting. Like pass the test plus 1. I am not recommending you to have that type of attitude of behavior, right? Try to find the behavior of the function. But anyway, so we have the function. This is the function. We want to analyze how this is behaving. Okay, so let's do it. So first of all, we need to we know that it's continuous, right? So it's going to go from infinity to negative infinity to positive infinity. So therefore, remember that one of the intervals was the following. The interval started at 0, right? So it starts from there. So we say that continuous to infinity from 0. So we do to infinity through negative infinity, through 0 to negative infinity, right? It started from 0. Then we do a test value at that point. And then we said, okay, so we go negative, right? Negative from 0 going infinity negative. Well, only God can count infinity up to infinity, right? Well, if only God can count up to infinity as it's negative, I am not really genius, right? Let's pick 1. 1 is starting from 0. I just pick negative 1. Make it easy, right? Why do I complicate my life? I'm just analyzing the thing. So, at that point, I test it with the second derivative. This is the function. And the second derivative of the function is this guy. So the second derivative is f of x double prime is equal to 60x cubed minus 60x squared. Okay. Now, when I go ahead and put test value equal 1, f prime of x double prime equal to minus 1. In this guy, that equal 1. So when I plot that 1 right here, so I said f negative 1 is equal to 60 negative 1 minus 60 negative 2. What? 1. But remember, this is, I do negative times a negative, so positive, times another negative is negative. Negative times a negative is a positive, because it's a square. Remember, this guy is a square. So over here I get negative times a negative is positive, times a negative is negative. Negative square is positive, but I have a minus. So in other words, this guy is equal to negative. This guy is going to be equal to negative 60. Why? Because minus 1 times minus 1 times minus 1. 1 times 1 negative becomes a positive. Okay? But then I get a negative, that becomes negative. Negative. Now, in this case, I got negative times a negative is a positive, but I have a negative here. So therefore, this is negative 60. Which in this case is negative 120. Negative 120. Interesting. So if I am getting negative 120 in that, am I concave up or concave down? That's a good question. Remember, we analyzing the behavior of f of x, which is this guy. Holding a cup like this, right? So if I am going like this, right? Holding it like this. Remember, I am taking the second derivative, right, of the function. Again, take this glass, flip it. Take the first derivative. Or something like this. Remember, the parabola look like this. And technically, this is f of x is equal to minus x squared. Right. So, now, I am holding like this. Taking the second derivative. The first derivative of this is negative, well, it's positive 2, negative 2x. Well, the second derivative is going to be negative. Alright? Why? Because the second derivative is, the first derivative, right? The first derivative of that guy is going to be negative 2x. Second derivative is going to be negative 2. See? So that is telling me that that guy, just by looking at it, is concave down. So, in this case, the sign, because this guy is negative 120, the sign of this is negative. The behavior is concave down. Let's do the next. Next, we evaluate it at the value, right? Because we need to use this guy. Okay, so now we follow the negative. We follow from zero to negative infinity. We plot 1 because we're not really the genius, the smartest, right? I cannot. Why can I put like a trillion negative? Doesn't make a lot of sense, right? No. One value, one is enough to see where that is going, and we know that is going negative, so it's concave down. Value of the second derivative, and then let me just put the two guys over there. It was too close. The parentheses almost looked like it was nothing over there. But anyway, now we evaluate this guy at this point. Okay. So now we say from 0 to 1. Now we have to evaluate that at 2 different points. Okay, so let's do this. Okay, if we do 0, well, 0, so plotting 0 for everything is that is going to be equal to 60, 0, minus 60, 0, 0, right? 0. So we know at that point, simply 0. So it's not going, not even concave up or concave down. But when we do something, when we do 1, right? Let's say, for example, we do 1 over here, and let's test it. Just for the heck of it, right? So let's do this, right? We do 1, and then we do 1 cubed minus 60, 1 squared. Again, this guy negative, this guy is not negative, so that's 1. And that's 1, so that's equal to 0. So this is both are 0. Okay, so now that we know that these guys both are 0 at these 2 points, we want to go ahead and do another number. So we know that this doesn't work at the moment, right? But is that the only number that is between 0 and 1? Really? Let's think about that. Is that the only number? No, because remember we're doing calculus, right? So we approximated things. It would be nice if we get a number using this interval, but we did not get anything. We got 0, right? That doesn't tell us too much because negative 0 and positive 0 is the same thing. It's just 0. And yeah, so let's try 1/2. So let's say f prime of f double prime of 1/2 is equal to 60 times 1/2, right? Minus 60 times 1/2 cubed squared. Okay? Now we can use the techniques of mathematics and say, okay, this guy goes over here how many times? Right? So this guy goes over here how many times? This goes, actually, let me just do this. See. Right, so if I take this, right, and I take this is technically when I cube that, right? So when I cube that, so when I cube that, when I cube this guy, this becomes 60, right? But this becomes what? This becomes what? This becomes when I cube this guy. Right, so f total prime of 1/2. Cube that, 60, right? That is 1. So that is 1/8. And then here, minus 60. And then that is 1/1/4. Now, come over here and I said, okay, so in this case, I cancel this guy by 4. Cancel this guy by what? 15. Cancel this guy by 15. Cancel this guy by what? 4. Right? So by 4, right? Cancel it by 4, right? Then I got 15. But over here, I got 1/4, right? I got 1/4, right? So then I get double prime of 1/2, right? So I get 1/4, right? So 15 times 1/4, right? Which technically this is, right? And then that's minus 15, which is equal to what? It's equal to 15/4 minus 15. When I do that, right? When I do this, this guy is equal to what? Let me just do it over here. So find the common denominator of this guy is 4, right? But then this one right here, this becomes right here becomes again 60 on the top, right? So it becomes 60 on the top, so it will be 15/4 minus 60/4, which is negative 45. Negative 45/4. Okay. So that's okay, so that's one. Right, so let's see. Okay, also, I think what it can be done too is the following. So basically, let me just undo this real quick. So, okay. Also, what you can do, you know that it's going to be a negative number. And we got a negative, right? Like I say, values over here don't care too much. But we can do something. Factor out this guy as I did it here, right? So now factor out. So now we got what? We got. Okay, so okay. Let's do it like this. We try both way, right? So let's say that you have in this case, right? So we have 1/8. Okay, so we have, let's say for example, factor out this guy, right? So if I factor out, this becomes 60x times 1 minus x minus 1. Okay. Okay, and this is a square. Remember, that's an x squared because that's how we factor it out, right? Now, let's plot half. Right? Plot the half on this. So we have 1, we have a 60 times negative half squared times minus 1, then negative half minus 1. This guy is equal to what? 30, right? And then I squared, but remember something. Order of operations, right? So we don't want to violate any rules. So 60 times a half square. Let's do the exponential first. So when I do the exponent, it's going to be what? Half a square. 60 half a square is going to be 1/4. Right? And then times half minus 1. Now, cancel this, this is equal to 15. Now, this is gone, that is equal to 15, right? Now, let's do something. Now, let's do something over here. So, let's do something over here, right? So, now we do f double prime of 1/2, right? So now we have 15, and over here we do parentheses first, right? So we do minus, okay, so right here we'll do 1/2 minus 2 over 2, find the common denominator inside. This is minus 1, right? This is greater than this, so it's minus 1 inside, times the 15, keeping the 2 on the bottom, is equal to negative 15 over 2. See? It's negative. So it is a negative number. So that means that this is, at this point, test point of between 0 and 1, a double prime, right? So at 1/2, right? At 1/2, this is equal to negative 15 over 2. Negative 15 over 2, right? So if that is negative 15 over 2, and that means that is negative, that means it is concave down. Okay, concave down. Okay, let's do the last one. Okay, and I will explain, right, so, but anyway, so what if, the question is, what if we did not factor it out, right? Let's see. Okay, so let's play with this. If we don't factor it out, right, what is this? So basically, don't factor it out, just do it as it is. Like 1/2, 60, right? And then over here, when I do 1/2, right? Minus 60 times 1/2. A square. This is cubed. Cube this is going to be 1/8. Double prime. 1/8, 60. 1/8. Minus 1/4 minus 60. 1/4. Okay, so this and this, right? So remember that this guy right here, this guy, 60 canceling this guy, right? Canceling this guy. I cancel this by what? I cancel this guy by, I cancel it by what? By 4. And I cancel the guy by 15. I cancel this guy by 4. I cancel this guy by 15. Okay? Now, do this. Right. So now I got a 15 over 4. Right? And then I got minus 15. Okay. Look at this. Look at this. Take the common denominator of that. 15 over 1 over 4 minus 60. Minus 60. Now, when I do that, so when I do that, it's 1/4, right? So yes. So minus. So if I do this, it's going to be what? It's going to be 15. It's going to be, because I'm common denominator of this guy, right? So this is going to be, it's going to be 60 over 4. Now, but it's, now this guy becomes what? Becomes 15 over, negative 15 over 4. Right? Now, no, 45, sorry. Negative 45. Okay, so negative 45, right? So now, the question is, which one will be more valuable? This was negative. And that's all that matters in this case. I think doing the factoring helped us to get a better reduced value. Unless probably if there is something here that, let's see, it can be done better, because that number cannot be reduced. I don't think it can be reduced. Let's see. So if it's 15, right? So 15, the only number that goes over here, in this case, is the only number that goes over here is 30, right? If I go by 30, so also that will be actually, I made a mistake, because this should be, if I am canceling this by 4, right, and I cancel this by 4, this is 2. See? This is 2. So this is 2. This is 2. Which is, this is. But then, the number here is simply, right, 30, which is 15 over 2. See? Technically, okay, the teacher, is it going to take points off of that? Yeah, probably. If it's a teacher that cares about values, in this case, not too much analyzing, they will say, okay, so you got a wrong number, I'm going to take the points off, right? The number, the sign, what matters over here, that's what we're looking for, right? But Okay, so we correct that. Okay, anyway, so. But factoring out helps out, right? So if you can factor it out, just always do it. Now, let's do the last one. So the last one we do what? We did right here, right? Now we do positive 0 to infinity. So we're going to 1 and see what the value is. So let me just complete this little table. Right? So let's do it. So f prime of x is equal to 60 x cubed, right? Minus 60x squared. Okay, so factor it out and you get 60x squared x minus 1. Okay, and remember that it's it's a double prime, which is second derivative. So take 1, right? We tested at 1, negative. Now we tested at 1 from 0 going infinity, positive. We tested at 1. So now it's 60 times 1 cubed minus 60 times 1 cubed, 1 square, I'm sorry. And that guy, right? In this case, right? So if that is the case, right, that probably not gonna help us too much, right? Now, if we factor it, is it going to help us out? Okay, let's try it both. Again, use the factor values and use this. In this case, it's just 0, isn't it? So, okay, so it's not helping out. 1, it doesn't matter. It's just 0. Okay, so let's test another value going positive. Okay. So technically 0 is not telling us anything. Now, let's do 60 at 2. Right? Now this guy is equal to 2. And this is square. And this is 60 at 2. This is cube, I'm sorry. This is square. Okay, so this is going to be double prime at 2. And it's going to be equal to what? It's going to be 60. It's going to be 8. This is going to be 60. And it's going to be 4, right? Okay, so that is the case. Let's do it real quick. So in this case, in this case, 8 times 60, right? And okay, so at 2 is equal to what? 480 minus 240 is equal to 240. Which in this case right here, you can actually see that it's equal to 240, which is positive, which is concave. If these two are down, then it's going to be up. Concave up. down and one up, right? So 2 concave down and 1 concave up. And I think that's enough for today. Hopefully you learned something, right? And I see you in the next video. Thank you for watching.